Welcome to another deep dive. We really appreciate you taking the time to join us for this one. I think you're going to find this really interesting. Today, we're going to do a deep dive into some of the findings presented at a recent conference featuring Armando Mei, Filippo Biondi, and Corrado Malanga. I don't know if you've heard of these guys. I think you probably have if you're listening to this. But anyway, we're going to do a deep dive into their work and just kind of a framing device here. A quote that they shared at the beginning of the conference attributed to Gilgamesh. Colui che vide il profondo vide ciò che era segreto, svelò ciò che era nascosto, e riportò un racconto di prima del diluvio. I probably didn't pronounce that correctly. But basically, the idea here is the person who saw the deep, saw what was secret, revealed what was hidden, and brought back a tale from before the flood. It's interesting.
Yeah, absolutely. So this idea that we're going to be looking into the deep, I guess, sort of, I think it was a metaphorical sense, but
Yeah.
we're going to look into the deep and see what we could find. And these guys are definitely looking into the deep and finding some very interesting things. So maybe to start with, just to give a little bit of context, you've got Armando Mei, whose work focuses on the astronomical alignments and trying to actually date these structures to an earlier time than what's conventionally believed. And then you've got Filippo Biondi, who's actually adapting some aerospace technology, things like SAR, synthetic aperture radar, and what they call sonic spectroscopy, to actually look inside these structures and see what's going on there. And then Corrado Malanga kind of brings his own unique research approaches that we'll get into a bit later.
So to start, I thought we'd jump into this thing called the Kephren Project. Now, the fact that Paul Boval, brother of Robert Boval, who is the guy who put forward the Orion correlation theory, was involved in this project early on, seems to lend a lot of credibility to the work of Mei and Biondi. Yeah. It's an interesting point. You've got Paul Boval, who is, he's a serious researcher in his own right, and he sees merit in Mei and Biondi's work, particularly the detailed work they did on the internal structure of the pyramid of Cheops or Khufu. What's interesting, though, is that Boval's focus is more on Kephren, while his brother, Robert Boval, as you said, the Orion correlation theory, he's thinking about the pyramids as a whole and the Sphinx, aligning to the stars around 10,500 BC. But Paul is looking specifically at some of these features that they're finding inside the pyramid that seem to align with Mei and Biondi's findings.
Yeah, and some of these features or findings are pretty incredible when you think about what they're saying they found using this advanced aerospace technology that has been adapted to look inside these structures. Now, let's start with the Great Pyramid, also known as Khufu, and more specifically the North Duct in the Queen's Chamber. Now, they said that there's evidence that someone tried to force their way into this duct.
Yeah, this is interesting because they report finding fragments on the floor of this very narrow duct, along with some scratch marks along the walls, suggesting a forced entry. What's interesting is they connect this to the caviglia, or ankle duct, which is located in the entrance passage to the king's chamber, suggesting that maybe someone had used this hidden passage to actually try and access the queen's chamber duct from the inside.
Yeah. Almost like a secret passage within a secret passage.
Yeah. And the artifacts that they're saying they found, the presence of these later objects inside these restricted spaces definitely is intriguing.
A ticket that looks like it's from the 70s or 80s and a Russian-made film reel were found inside the Queen's chamber duct. So how did they get there?
Well, that's the question, isn't it? Did someone accidentally drop them? That's possible, but it makes you wonder, doesn't it, if someone would intentionally leave something like that.
It makes you wonder about the history of access to these.
Exactly.
These very secret places.
Right. Yeah. And it really lends weight to this idea that their remote sensing is picking up on something real.
Right. Okay. So moving up within the Great Pyramid, now to the Great Gallery, there are indications of some blocked passageways there as well that seem to match with their internal maps.
So here they've identified a granite block that seems to be blocking a passage right at the top of the ascending corridor. And this blockage corresponds to what their models show should be there. But in addition to this, they've also found another sealed opening higher up on the east wall of the Great Gallery, which again is also exactly where their models suggest it should be. So again, you've got this, it's not just an anomaly. This is something that seems to be,
by design.
Intentional, yeah. Okay, and then there was also a hidden passage in the king's chamber behind a wall. That was built in the 1980s. Yeah. This is really interesting. So behind this more modern wall, there's a passage that actually heads downwards, and then it forks, with one branch going up and then the other one continuing down to what's described as a well. Now, this downward path that leads to the well is particularly interesting because it could actually be the other end of the entry point to the Queen's Chamber North Duct.
Oh, wow.
Okay, so this is getting really interesting. All right.
Yeah.
Now let's move on to the Pyramid of Khephren. Now there were some restricted areas there as well that were a little bit concerning.
Yeah. Specifically in the descending passage where scan pyramids had placed their muon detectors, Mei and his team were actually denied access beyond this point.
Hmm.
Which, makes you wonder, why is that? Is there something that's been damaged?
Well, they also talk about some drilling that went on in the Queen's Chamber of the Great Pyramid, so who knows what kind of shenanigans are going on over there.
Exactly.
Okay, so in the horizontal corridor that leads to Belzoni's chamber in Khephren, they noted a block with an unusual shape and a niche that appear to be blocked off.
Yeah. So this uniquely shaped block, it stands out from the regular blocks, right? Which suggests that maybe it's concealing something. And similarly, you've got this niche containing a pink granite block, but it's been blocked by a sandstone block. It's almost like someone's intentionally trying to hide something. So again, this raises all kinds of questions.
Right. Okay, now let's talk about Belzoni's chamber in Khephren. Mei's team entered Belzoni's chamber exactly 207 years after Belzoni. That's pretty interesting.
A little coincidence, huh?
Yeah, a cosmic coincidence. Yeah. So now what about the shafts? There are opposing shafts in Belzoni's chamber, but they differ from the ones that we see in the Great Pyramid.
Yeah, so these opposing shafts actually suggest a double pair of shafts, unlike what we see in the king's and queen's chambers of Khufu, which only have a single pair. And there were drilled holes in the paving blocks around the sarcophagus.
I notice you put that in air quotes.
Yeah. And that's because Mei's interpretation of these holes is that they're actually attachment points that would have been used to move a lid, which, suggests that this wasn't necessarily a sarcophagus at all. And lastly, they found a limestone block at the end of the descending passage, which they believe could have been used as a closing mechanism.
Right. So all of this really suggests that these pyramids are far more complex than we once thought.
Right.
Yeah.
Absolutely. It challenges that whole idea of a simple tomb.
Okay. So before we get into some of the advanced technology, let's just kind of review a little bit our historical understanding of the Great Pyramid. We know about the early exploration by Belzoni and by Perring, who kind of picked up where Belzoni left off. So what was known before these guys?
Yeah. Well, obviously we had the work of those early explorers, right? Like Belzoni, Perring, which was really foundational for mapping those main passageways and chambers. And Belzoni's work was significant, especially in opening up the areas we know today. And Perring continued this, looking into the upper regions, exploring what are known as the chambers of construction above the king's chamber. But obviously, those were physical explorations, limited by the technology of the time.
Right. And then in 1967, Luis Alvarez did this muon experiment, using muons to try and see if there were any hidden chambers.
Yeah, this was a pretty groundbreaking experiment at the time. This was a really early attempt to use muons to see inside the pyramid. But the thing about this experiment is it only scanned 18% of the total volume of the pyramid, and it didn't find any new voids. So it seems like the technology at the time just wasn't quite sensitive enough.
Right. And interestingly, there's a recent study by the University of Riga that actually found fractures in the northeast area of the Great Pyramid, near the base. So again, that suggests possible internal collapses.
It's an independent study, and it suggests that there could be internal voids or collapses.
Okay. So let's move on to the Valley Temple and the Sphinx now.
Yeah.
Now, Mei talked about the Valley Temple having dual construction. What is that?
Yeah. The Valley Temple actually has a sandstone exterior, and it shows signs of water erosion, suggesting it was exposed to water for a very long time. But the interior core is constructed from these massive granite blocks. So why this difference? It makes you think about, was it built in different phases? What was its original purpose? Lots of questions.
Right. Yeah. There's this idea that it was built by Khephren. And it seems like that's based on one headless statue found in a well.
It seems like pretty flimsy evidence when you think about it.
Right. It was found upside down as well.
Upside down in a well. Yeah.
That would be interesting.
It makes you wonder if maybe it was placed there later or, who knows? It's just speculation at this point. But it's definitely interesting.
Yeah, the granite blocks in the interior of the Valley Temple weigh between 70 and 80 tons. And they have these amazingly precise cuts, even curved joints. That seems like it would have been beyond the technology of the Old Kingdom.
Yeah. So to work granite on that scale to such a precise degree, especially creating curved cuts that fit together perfectly, with the tools and techniques of that era, that would have been a monumental task.
Right.
If not impossible.
Yeah. So Mei also had this interesting idea about the layout of the Valley Temple, that it actually resembles an electrical circuit or even a microchip.
Yeah, that's where Mei gets a little bit more out there.
Yeah. A little out there.
But I like it. But it was interesting. He actually took the elements, like, for instance, the fork shape that he sees in the layout, and he interprets that as representing the number 3.
Okay.
And then you've got the colonnade with its 16 columns, and that reduces to 7.
Hmm.
And then he has a niche, which represents the number 1. So he's got this number 371.
Right.
And he points out that 371 is actually an anagram of 137.
Right.
Which has, various significances. And then he ties these numbers back to, the Hebrew letter shin, which is associated with reincarnation, and the Greek letter tau, which symbolizes power. So he's making these connections to, symbolic meanings.
Right.
And it's interesting, isn't it? It makes you wonder if there's some kind of, language embedded in these forms.
The deeper meaning.
Yeah.
Okay. So this kind of ties in with May's Septepi dating theory, which places the construction of the Giza pyramids at 36,400 BC.
Yeah. This is a much earlier date than what's conventionally accepted.
Robert Bovale's theory, the Orion correlation theory, puts it at around 10,500 BC.
Right. But that's only looking at the 3 main pyramids and the Sphinx. Right. And how they align to certain constellations at that time.
Right.
But May is taking a much broader approach. He's looking at all the monuments on the Giza Plateau, not just the pyramids, and he's taking into account their east-west alignment and how that relates to the celestial vault.
And based on that, he's saying 36,400 BC.
Right, which is, a huge difference.
Huge, yeah. So if that's true, then the question becomes, who built these?
Right.
Who was around back then? And how do they even communicate?
Right. So May also pointed out the fact that there are no hieroglyphs inside the Giza pyramids themselves. And he sort of dismisses the graffiti that's found in the Great Pyramid.
Right, as a known forgery.
As a forgery, right.
Right.
Which raises even more questions, because if they predate the development of hieroglyphs, how are they communicating? What other forms of communication are they using?
Right. So what's the answer?
Well, May suggests the idea of the language of number. This idea that mathematics and numerical relationships could be a form of universal language,
Right.
a language that transcends, spoken or written language.
So a language that's kind of eternal?
Yeah. Exactly. And the precision that we see in the astronomical alignments at Giza does suggest that whoever built these structures had a very deep understanding of celestial mechanics. And May is kind of suggesting that this understanding wasn't just, a practical thing, but it was also very much tied to their spiritual beliefs.
Yeah.
And their concept of, the cosmos and the underworld.
Right. So maybe this underworld or Amenti is a dimension or a realm of existence that's somehow connected to these numbers.
Yeah. And it's interesting because, he's connecting these ideas to the numerous non-dynastic wells that are found on the Giza Plateau.
Right, yeah. So these wells don't really fit in with the traditional narrative of dynastic Egypt.
Right. And they're kind of all over the place.
They are, yeah.
Yeah.
So we also talked about the concept of duality. This is a big part of ancient Egyptian thought.
Right. So the Ka and the Ba. And linear time versus circular time.
Right. But then May kind of introduces this third element.
Right. Yeah. So we've got this tripartite division. Amenti as the underworld, Rasta as the surface, and then Duat as the void.
So you've got these 3 different aspects of existence.
All right.
That kind of transcends duality.
Okay.
So May also talked about these traces of water erosion on specific blocks on the Great Pyramid.
Yeah. It's interesting because he suggests that this points to a demolition of part of the pyramid's outer casing around 10,500 BC.
That's interesting.
Which would then expose these blocks to water.
Right.
Which aligns with Boval's timeline.
Right, okay.
So there could be some connection there.
So is he saying that the pyramid was built and then part of it was demolished?
I think that's what he's implying, yeah. And then, of course, there's this paved plateau on the east side of the pyramid. It's made from these massive limestone blocks that are cut so precisely, and they seem to encircle the whole structure.
Yeah, it's almost like a giant courtyard.
Yeah, and it's a really interesting feature.
It is. Okay, so now we're going to get into this concept of space sonar. That sounds like a bit of a contradiction, doesn't it?
It does, right? How do you have sonar in space?
So what is this all about?
Well, Biondi explained that it's not sonar in the traditional sense. It's actually SAR, synthetic aperture radar.
Okay. And how does that work?
So SAR uses electromagnetic waves, specifically radio waves, to create images of the Earth's surface. And it works by sending out pulses of radio waves from a satellite and then measuring the time it takes for them to bounce back.
So it's kind of like sonar, but instead of sound waves, they're using radio waves.
Right. Exactly. But what's really ingenious about SAR is this concept of a synthetic aperture.
Okay, what does that mean?
So the aperture of a radar antenna determines the resolution of the image. But physically building a giant antenna on a satellite just isn't practical. So they use this technique where they move a smaller antenna along the satellite's path and collect multiple echoes. And then, through some pretty complex processing, they combine this data to create a synthetic aperture that's much larger than the actual antenna.
So it's like taking multiple images and then stitching them together.
Right. It's kind of like a panorama, but with radar.
Okay, and he showed us this equation.
Yeah.
Resolution equals lambda times range divided by aperture. Now, what is he trying to tell us here?
Basically, this equation shows us that to get high resolution, we need a small wavelength, a small range, and a large aperture. But the problem is, we're talking about satellites that are hundreds of kilometers away from the Earth, so the range is always going to be very large.
Right, okay. So to compensate for that, they need to use a shorter wavelength and a larger aperture.
Exactly.
Okay. And then he brought up this concept of the Fourier transform. Now, that sounds pretty complex, but what does it have to do with radar?
So the Fourier transform is a mathematical tool that's used to break down complex signals into their individual frequencies. And it's used in SAR to focus the radar data.
So it's like taking a blurry image and making it sharp.
Right. It's kind of like a sharpening filter, but for radar.
Okay. And then he talked about the Doppler effect. Now, that's something I think most people are familiar with, the way a siren changes pitch as it passes by. But how does that apply to SAR?
So the Doppler effect also comes into play with SAR because the satellite is moving relative to the Earth. And this causes a slight shift in the frequency of the radar signal.
Okay.
And by analyzing the shift, they can get even better resolution, particularly in the direction the satellite is moving. So it's like another level of detail that they can add to the image.
Okay. But he did say that these radar images aren't like photographs. They're more like maps.
Right. So they're a representation of the Earth's surface.
Right.
Based on how those radar waves are reflected back.
Okay, now here's where it gets really interesting. This concept of space sonar involves transforming photonic energy into phonic energy. So they're taking light and turning it into sound. How is that even possible?
Yeah. So this is where they've developed a new technique. They call it the sub-apertures Doppler method. And this method allows them to detect these very tiny movements of the Earth's surface.
Okay.
Down to the sub-millimeter level.
Wow.
So what they do is they process the radar data in smaller chunks, which they call sub-apertures.
Okay.
And then they very carefully track the Doppler shifts over time as the satellite moves in its orbit.
Okay.
So by doing this, they can actually see these minute changes in the surface of the Earth.
So are they saying that the Earth is constantly vibrating?
It is, yeah. It's always moving. And these vibrations can actually tell us a lot about what's going on beneath the surface. And what they've discovered is that when the radar waves hit the ground, some of that energy is actually converted into sound waves, or phonons.
Okay, so these sound waves, they can travel through the ground.
Right? They penetrate the ground.
Right.
And then when they hit something, they get reflected back up, and then they can be detected as what are called evanescent waves.
Yeah.
Just above the surface.
Okay. And he said that granite is actually a really good material for this.
Yeah. It's a great conductor of sound waves, which is why the pyramids are actually ideal for this kind of analysis, because they're made of granite, and these waves, they're coherent, which means they retain their shape and structure.
Okay.
So they can travel deeper, and they can provide more detailed information about what's going on below the surface.
Right. Okay. So he made this interesting analogy to a space turntable where the Earth is like the vinyl record.
Yeah. It's
Yeah.
a good way to think about it, right?
Mm-hmm.
So you've got the Earth, which is constantly rotating, like the vinyl, and then you've got the radar beam, which is like the needle, scanning across the surface. And just like a needle can pick up the vibrations in a record groove, the radar can pick up these minute vibrations in the Earth's surface.
Okay. Now, after all of that, they use this algorithm called tomographic inversion to create images of what's underground.
Mm-hmm.
How does that work?
So this is where they take all that sonic data and they basically reconstruct a 3D picture of the subsurface. And they do this using a model of interconnected springs and masses. And they apply the Fourier transform again, but this time to the sonic signal.
So they're taking the sound waves and they're converting them into images.
Right, exactly.
Okay. Now, they were able to validate this technique.
Yeah. So the Scan Pyramids project, which used muon tomography, later discovered this corridor of discord in the Great Pyramid.
Right.
And this corridor actually matched up with some of their earlier findings, which really validated their method.
So they had predicted this corridor before it was actually found.
Right, exactly. So it was a really big moment for them.
That's pretty amazing.
It is.
Okay. Now, they also showed some case studies of how this technology is being used beyond Giza. Now, let's start with the Gran Sasso Laboratory.
Yeah. So this is a laboratory that's located deep beneath a mountain in Italy.
Right.
And their tomography was able to clearly show this whole network of tunnels and research facilities.
So they were able to see through solid rock.
Yeah. Pretty amazing.
Yeah. Okay. So then they also showed a tomography of the Mosul Dam in Iraq.
Yeah. So here they were able to actually see the internal service gallery of the dam and even what appeared to be the turbine area.
So they could see inside this massive concrete structure.
Yeah.
Okay. And then they showed the Gotthard Tunnel in Switzerland.
Right. And the tomography was able to show the whole tunnel system all the way through the mountain.
Wow. Okay.
Yeah.
And they also mentioned that they have a PCT international patent on this method.
Right. So this is a unique and patented technology, and it's currently active in Malta.
Okay. So now this brings us to the real deep dive into Khephrun's pyramid. Now, their findings here are pretty shocking because they suggest that the interior of this pyramid is far more complex than we ever thought.
Yeah. So initially they thought that Khephrun's interior was pretty much empty, based on our conventional understanding.
Right.
But the tomographic analysis suggested otherwise.
Okay. Now, they did have some problems with distortion because of the angle of the satellite's antenna.
Yeah.
So how did they overcome that?
Yeah. So the radar antenna on the satellite wasn't perfectly aligned with the pyramid, and this created distortions in the images,
Okay.
and they had to account for this
Yeah.
in their analysis.
Okay. So they looked at multiple images taken from different angles.
Yep.
And they also use this concept called the Trippa effect. What is that?
Yeah. So the Trippa effect is basically a way of stretching or compressing the tomographic data to highlight certain features.
Okay.
But it's important to note that this doesn't change the data itself. It's just a way of manipulating the visual representation of the data to make certain features more visible.
Okay. And through this analysis, they were able to discover some really interesting things. Now, one of the things they found was a series of layered structures that had what they call a pergola-like roof. Now, what's interesting is that this resembles the Z structure that they had previously identified in the Great Pyramid.
Yeah. So this suggests that there may be a common design element between the two pyramids.
Okay. Now, they also found these characteristic light patches, which they interpret as areas of differing vibration.
Right. So these patches remain consistent across different views, which suggests that they're not just random noise, but that they actually represent real structures.
Okay. Now, they also saw two bright paths descending into the pyramid, which they believe correspond to the known entrance passages.
Yeah. So in some of the images, these paths appear as two separate lines because of the angle of the radar, but they do seem to match up with what we already know about the pyramid's interior.
Okay. So, again, this kind of validates their method, that they're seeing things that are actually there.
Right.
Okay. Now, they also noticed that some areas were more luminous than others.
Yeah. And this suggests that the underlying structures are causing variations in the way that the sound waves are being transmitted and reflected.
Okay. And around some of the brightest areas, they saw these bluish halos.
Yeah. So they interpret these halos as regions of weaker vibration.
Okay. Now, here's where it gets really interesting. They started to see these ascending bright paths on the right side of some of the tomographic images. And these paths had periodic horizontal segments. It's almost like a comb.
Yeah. They described it as comb-like or diapason-like, which means tuning fork.
Right.
And these forms had a consistent spacing in some area.
Okay. So that suggests that they're not random, but that they were deliberately constructed.
Right. It seems like they're part of some kind of intentional design.
Yeah.
Okay.
So they also look at vertical slices.
Yeah. So these vertical slices showed that these structures are even closer to ground level.
Okay. And when they zoomed in on these diapason shapes, they noticed internal disturbances and lines. And this led them to believe that these shapes are actually hollow and that there's something inside them.
Yeah. They believe that there's something rectangular inside them that's transparent to radar.
Okay. So they're saying that these structures are like hollow tubes with something inside.
Right. And the disturbances that they're seeing are caused by the interaction between the radar waves and whatever's inside those tubes.
Okay. Now, they concluded that there are about 7 of these diapason objects extending from left to right, with a possible additional corridor at their apex.
Right. So this is a completely different picture of what's inside Khephrun than what we're used to.
Right. Now, he also showed some real-world examples of similar structures.
Yeah, so he showed us the roof of a library
Okay.
and some supports within a dam to kind of give us an analogy for what these shapes might be.
Okay. Now, when they looked at a tomography from a different angle, they saw this flattened image of the pyramid and a black rectangle, which they interpret as a void, with a smaller black square inside it. And these were connected by 5 Z structures.
Right. And he mentioned that the Trippa effect helped them understand that the perceived size in this image might be distorted because of the angle.
Okay. And then another tomography revealed some descending coiled structures on 2 different levels.
Yeah. So again, just adding more complexity to the picture.
Right. Okay. And then they looked at a north entry view, and they saw 8 descending tubes arranged in 2 rows.
Right. So these tubes had differing brightness, which suggests that they might be made of different materials.
Okay. And when they looked at higher resolution views of these tubes, they saw that there were 4 in front and 4 behind. And there was also this surrounding spring-like structure. That led down to a solid base.
Yeah. So they were able to confirm these findings in other tomographies. So again, just adding more evidence that these structures are real.
Okay. And then they focused in on 2 of the brightest tubes. And they saw that there were variations in brightness inside these tubes, almost like 3 distinct levels.
Yeah. So this led them to believe that these tubes are actually hollow and that they might contain something inside.
Okay, so it's like a tube within a tube.
Right. Exactly.
Okay. Now, when they pulled back to look at the entire pyramid, they could see these darker cone shapes at the edges.
Right. So these cone shapes represent the corners of the pyramid where there's less vibration. And then they were able to identify a rectangular area at the bottom of the image where 4 of the descending channels seemed to terminate.
Okay, so it sounds like they're all connected to this lower level.
Yeah. Seems like there's some kind of structure down there.
Right, okay. Now, he did a depth calculation and estimated that this lower level is about 648 meters down.
Right. And he made a connection between that number and the golden ratio.
Wow, okay.
Which is really interesting because it suggests that there might be some kind of intentional geometric proportions built into the pyramid's design.
Okay, and then he showed us some examples of tubular structures from around the world.
Yeah. So he showed us St. Patrick's Well in Italy, the step wells in India, and the underground city of Derinkuyu in Turkey.
Right.
And these structures are all very ancient, but they all have similar features, which suggests that there might be some kind of common ancient building tradition that we've lost track of.
Right, okay. So they also used AI analysis on the tomographic data.
Yeah.
And it seems like the AI was able to confirm their findings.
Yeah. So the AI was able to identify voids, vertical structures, horizontal anomalies, and it even generated its own 3D sketch, which seemed to match up pretty well with their interpretation.
So the AI is seeing the same things they're seeing.
Yeah.
And then he showed us this really cool flyover of the AI-generated 3D reconstruction.
Yeah, and this showed us a water layer at about 35 meters down.
Right.
These deeper wells.
Okay.
And these 2 lower chambers that they're calling the Amenti chambers.
Okay.
And it also showed us the 5 interconnected Z structures and how they relate to the pyramid's sides.
Wow. So this is a really complex picture.
Yeah, it is. And the parts of Kefren that we've traditionally explored are actually below ground level.
Oh, really?
Yeah. So this is a whole other level of the pyramid that we've never really seen before.
Okay.